Good morning, everybody. Today we'll discuss on iron 2 ions. Iron is a gray metal. It is a heavy metal. It is reactive. From the periodic table, you can identify the position of iron. Iron is here. Iron has proton number 26 and a relative atomic mass of 55.8. Iron reacts with air and water to form rust. This is rusting of iron. This is another example of rusting of iron. This is a horseshoe made of metal iron, dense metal, and there is rusting on it. Iron is a transition metal. This is the transition metal region. So since iron is here, it is a transition metal. Its ions or hydrated ions are colored. Aqueous iron 2 ion is green. This is iron 2 ion. It is green. It is dilute, so not so green, but it's green. Iron 3 ion is brown. Iron 2 sulfate is green in color. Iron 2 sulfate dissolves in water to give a green solution. Iron 2 sulfate dissolves in water to produce aqueous iron 2 ions and sulfate ions. Today we'll discuss on the iron 2 ion. Aqueous iron 2 ion is bonded datively to 6 water molecules. Note the oxygen atom of the water molecule, which is bonded to the central iron 2 ion. The overall charge is +2. The square brackets indicate the coordination sphere. In the coordination sphere, there are coordinate bonds or dative bonds between oxygen or water molecules and iron 2 orbitals. Water molecule is a ligand. Water molecule has no charge, so it is a neutral ligand. It is a ligand because it has a lone pair of electrons. It has at least one lone pair of electrons. How do we test the presence of iron 2 in a solution? We suspect it to contain iron 2 solution. How are we going to proceed as a chemist to test its presence in the solution? We can opt for sodium hydroxide solution to do the test. When sodium hydroxide is added to the solution, a green precipitate is formed. The green precipitate is iron 2 hydroxide. So I am going to take a small amount of iron 2, not so much, a small amount, 1 centimeter cube. And to this, I am adding now sodium hydroxide, aqueous sodium hydroxide. Slowly I add, I observe, a green precipitate is obtained. A green precipitate is obtained. If I allow the green precipitate to stand for some time, a brown precipitate will be seen. If you observe carefully at the top of the solution, it starts becoming brown. So I leave it aside for some time, then we'll observe again. Iron 2 ions oxidizes to iron 3 ions. The oxidation of iron 2 ion is rapid in presence of hydroxide ion. This is shown by its electrode potential value. Iron 2 hydroxide in presence of hydroxide ions converted to iron 3 hydroxide. The E theta value is given as plus 0.564. This value can be obtained from the data booklet. If more sodium hydroxide is added, the precipitate will not dissolve. The formula of iron 2 hydroxide is in fact this one. 2 water molecules have been substituted by the OH group of atoms. 4 of water molecules remain. OH minus ion is also a ligand. Water also is a ligand. This is a simplified form of writing the formula. FeOH twice H2O 6 H2O4, not 6, H2O4, modification done, and this is also a complex. This is the spatial formula. We call it the spatial formula of this compound. This is the spatial formula. It has an octahedral shape. It is FeOH twice or FeOH twice H2O6, like this one. Or we can write it simply FeOH twice. Or simply we can write it FeOH twice. OH minus is a ligand, negative ligand. H2O is a ligand, neutral ligand. The shape of the complex is octahedral, to remind you of. So whenever we want to test the presence of iron 2, we take a small amount of the solution. It should not be blue. It may be colorless because dilute solution, or if you observe carefully, it will have a pale green tinge color. You add NaOH, you obtain a white precipitate, a green precipitate, and slowly the green precipitate turning brown. This is the test for iron 2 ion. Thank you very much for your attention. See you another time for another lesson. Goodbye.